Hey guys, tonight we slip into the strangest role you've probably ever imagined. Because you're about to become a star. Not a celebrity, not someone walking the red carpet, but an actual astronomical furnace of fire, pressure, and light. Picture yourself adrift in an endless darkness, surrounded by a cold sea of gas and dust, until one faint spark inside you begins to tremble with promise. It's not glamorous yet, more like awkward baby photos of a glowing ember. But trust me, this will escalate quickly. You're going to burn brighter than 1 billion bonfires, and you'll probably roast yourself long before you learn how to be chill about it. You probably won't survive this. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And I'd love to know, drop your location and local time in the comments, so I can see just where in the world you're tuning in from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first thing you notice is pressure, unbearable pressure. Gas collapses inward, crushing tighter and tighter, all thanks to gravity, because gravity always wins. You start as nothing special, just a cool, anonymous cloud of hydrogen atoms drifting in the void, but the universe loves drama. Small disturbances ripple through you, like whispers from nearby exploding stars, nudging and shoving particles into clumps. Slowly, but irresistibly, your matter gathers together, until you're no longer just mist in the wind. You're becoming dense enough to feel your own pull. The truth is obvious. Stars aren't born overnight. They're sculpted out of stubbornness and gravity's insistence that nothing gets to float around forever. Deep inside your core, temperature climbs with terrifying patience. At 10 million degrees, ordinary atoms begin to panic, electrons squeezed so close to protons they barely keep their distance. You feel the first stirrings of nuclear fusion, the wildest party the universe throws. But at this stage, you're just hovering on the edge, glowing faintly in infrared like an embarrassed match that doesn't want to be seen. Astronomers call this your protostar phase, though you're more like an unlit barbecue. Everyone knows something big is coming, but no one dares stand too close yet. And here's a quirky tidbit. Some protostars wear cocoons. Clouds of dust and gas swaddle them, making them invisible in ordinary light. Only infrared telescopes can spy through the blanket, revealing the infant star fidgeting inside. It's as if you're born shy, hiding your glow from curious onlookers. Historians still argue whether the earliest sky watchers, staring at mysterious dark patches in the Milky Way, might have intuited that such invisible births were happening inside. No one can prove it, but it's a fun thought, that even without telescopes, humans sense that the dark was hiding something luminous. As the crush continues, your shape tightens. You begin to spin faster, a cosmic figure skater pulling in arms, until your once lazy swirl accelerates into a dizzy whirl. Around you, some gas flattens into a disk, a messy halo where future planets will form. For now, though, the spotlight is on you. In your belly, the heat builds until the atoms themselves surrender, fusing hydrogen into helium, releasing light that floods your interior. It's the moment your story officially begins. You ignite, and the cosmos registers your presence with quiet approval. The obvious truth here is this. Without fusion, you're just another gas cloud. With fusion, you're a star, a fire that will burn for millions or billions of years. The line between being nobody and being cosmic royalty is only a few million degrees wide. You feel yourself settle into balance. Gravity tries to crush you smaller, but the furious energy of fusion pushes outward, inflating you like a glowing balloon. For the first time, you're stable, held together by the perfect tug-of-war between collapse and explosion. But don't get too comfortable. Photons, the packets of light your core keeps spitting out, don't exactly rush to the surface. They ricochet endlessly, scattering around like pinballs, taking tens of thousands of years just to escape your belly. Imagine shouting in a crowded concert and hearing your own voice echo back 1 million times before reaching the door. That's how light feels inside you. So while you think you're shining, the photons at your surface today were born long before anything on Earth had legs. You continue to tighten, still glowing brighter. The dust cocoon around you starts thinning as your light pushes it away, carving a cavity in the darkness. To an outside observer, You'd finally look like a star being born, flaring against the night with fresh radiance. For you, though, it feels less like glory and more like breathing for the first time after holding it in far too long. You exhale a wind, a steady outflow of particles that sweeps through your surroundings, clearing space like a leaf blower at full throttle. This wind has consequences. Stray clumps of gas nearby are blasted aside, but some of them survive, circling and condensing into chunks. You don't notice yet, but these will one day be planets, moons, and asteroids, all thanks to your stellar tantrum. In a sense, every rock that will ever orbit you is carved by your early breath. It's like discovering that your messy first steps as a toddler rearranged the furniture of an entire solar system. Here's another quirky truth. Stars of your size aren't born quietly. You actually give off bursts of radiation and jets, sometimes spitting twin beams of material out along your poles like fire hoses gone rogue. Astronomers call these Herbig-Haro objects, which sounds less like cosmic physics and more like a brand of expensive bottled water. But these streams of plasma, glowing across light years, mark your neighborhood as a construction site. Anyone watching would know. Something enormous is happening here. As the chaos settles, you realize you're now luminous, a newborn star pulsing in white-hot brilliance. To you, it feels natural. You simply are what you are. But to distant eyes, you've gone from invisible shadow to beacon, joining the company of billions scattered across the galaxy. Some will live short, violent lives. Others will linger gently. Your destiny is already written in your mass, the one number that decides whether you end up as a gentle white dwarf or as a catastrophic supernova. You don't know which road you're on yet, but you'll find out. For now, just breathe in your fusion fire. Feel how it fills you with stability, a heartbeat that will pulse for eons. This is your first moment of true stardom. The dust clears, your light escapes, and your career begins. No red carpet. No paparazzi, just a sky so deep that your glow might reach creatures someday, somewhere, who stare upward and whisper, "A star was born here." You feel it constantly now, that grip that refuses to let go. Gravity isn't your friend, but it's the only reason you exist. Imagine an invisible hand squeezing you from every direction, an endless embrace so strong that your very atoms are welded together under its pressure. You're pinned into shape by this cosmic hug, and there's no escape. The more you resist, the tighter it squeezes. And here's the cruel joke. The harder gravity crushes you, the hotter you burn, and the hotter you burn, the more desperately you push back. The result is your whole existence balanced between two impossible forces. Everywhere inside you, hydrogen atoms are slamming into one another, merging into helium with little bursts of energy. But fusion wouldn't happen at all without gravity shoving those atoms close enough to kiss. If your grip loosened, the whole party would fizzle out like a forgotten candle in the rain. The obvious truth is that stars aren't free-floating fireworks. They're prisoners of their own mass, eternally wrestling against their own weight. And that weight is staggering. You probably imagine yourself as a neat glowing ball, but in reality you're more like a boiling cauldron of plasma, with your outer layers constantly trying to collapse inward. Think of it like standing under an avalanche that never ends, except you're the mountain too. Without the pressure, you'd collapse into nothing. With too much pressure, you'd detonate in a violent flash. The miracle is that you land right in between. Let's throw in a quirky tidbit. Your surface, the photosphere, doesn't even look like a solid wall. It's a frothing ocean of convective cells, each about the size of continents on Earth. Hot gas rises, cools, and sinks, over and over, making you look like a pot of rice boiling furiously on a stove. No wonder the ancients stared at the sun and thought it must be alive. It literally seethes with movement. Historians still argue whether early civilizations were closer to the truth than we give them credit for. After all, what is a star if not a giant, blazing organism that eats fuel and excretes light? But don't forget how brutal the squeeze feels from the inside. Your core is under pressures so high they make human analogies fall apart. Imagine balancing millions of elephants on every square inch of your skin. Then multiply that by a factor so large, your imagination catches fire before it finishes the math. That's your everyday reality. You may feel grand and luminous on the outside, but deep inside you, matter itself is screaming. Electrons are stripped from nuclei, creating a soup where nothing resembles what Earth calls normal. Gravity is patient, though. It never gets bored of pulling. The more hydrogen you burn, the more helium piles up in your core, making it denser, heavier, and more stubborn. It's like your belly filling with lead bricks while you're still expected to keep dancing. You keep fusing hydrogen around the helium, desperately trying to keep up with the squeeze. And for now, you manage. Light, meanwhile, takes its sweet time escaping. Those photons born in the furnace of your center get caught in the traffic jam of a lifetime, bouncing around for tens of thousands, sometimes millions, of years before reaching your surface. So when you shine, what people see is your delayed broadcast, light that fought its way through layer after layer of dense plasma before finally escaping. In a way, you're the slowest celebrity ever. By the time you glow across someone's night sky, the photons are ancient relics of who you used to be. And oh, the size of you. Even an average star like the Sun is so big you could fit over 1,000,000 Earths inside. But what you notice most is not the scale, it's the density at your heart. That squeeze from gravity keeps you from blowing apart despite the unimaginable energy inside you. Without it, you'd be nothing more than a sad puff of gas dispersing into the void. Gravity might be your tormentor, but it's also your stage manager, making sure your performance never skips a beat. It's worth admitting, stars of different sizes experience gravity's embrace differently. If you had been much smaller, you might never have gotten hot enough for fusion. You'd be stuck forever as a brown dwarf, a cosmic almost but not quite, glowing faintly in infrared, never quite shining. If you had been much larger, gravity would have squeezed you so violently that you'd burn through your fuel in mere millions of years, collapsing and exploding in spectacular death throes. Your destiny was decided the moment gravity claimed you. Your mass is your fate card. There's a gentle irony here. As much as you think of yourself as independent, you're really just gravity's performance art. The universe designed you as a balancing act. Fall inward, push outward, repeat. That's the rhythm of your life, and you'll keep it up until you can't anymore. For now, though, you're stable, luminous, and magnificent. The squeeze is relentless, but it's also what makes you shine. And here's a comforting truth. If stars could be comforted, your prison is also your pedestal. You may be trapped in gravity's arms, but that embrace makes you the most important beacon in the universe, feeding worlds with light and warmth, holding galaxies together in cosmic tapestries. You are the paradox of weight and radiance, forever squeezed, forever glowing. So you keep burning, keep balancing, keep holding that impossible pose. And if anyone down there on some tiny blue planet looks up at you, they'll never sense the endless crushing you endure. To them, you'll simply look steady, timeless, and serene, shining as though nothing in the universe could ever trouble you. Deep inside you, a new rhythm takes over. It isn't the quiet, hesitant flicker of your birth anymore. It's the steady, confident heartbeat of nuclear fusion in full swing. You feel it with every pulse. Protons colliding at incomprehensible speeds, sticking together in a dance of unimaginable violence and elegance. The result? Helium. Every second, trillions upon trillions of hydrogen atoms vanish into tighter, heavier forms, and in the process, you flood your body with light. Fusion is no longer a fragile spark. It's your entire identity. This is the proton-proton chain, your favorite recipe. Step 1. Smash 2 protons together until one transforms into a neutron, and suddenly you've got a deuterium nucleus. Step 2. Toss in another proton, and voila, helium-3. Step 3. Take 2 of those helium-3s and fuse them into helium-4, spitting out stray protons like confetti. The payoff is energy, pure and unstoppable, released as photons and neutrinos. To you, this process doesn't feel like science. It feels like breathing, like the most natural thing you could do. The obvious truth is simple. Fusion is what makes you a star. Without it, you'd just be another cold, lifeless hunk of gas sulking in the void. But there's a quirky side to your fusion party. The neutrinos you create, the nearly massless ghost particles, barely notice you exist. They zip through your entire body at nearly the speed of light, ignoring all the matter in their way. In fact, billions of them are streaming through Earth and through the humans staring at the sky, every second without so much as a polite hello. Astronomers build massive underground detectors just to catch the rare one that bumps into anything. If neutrinos were party guests, they'd be the ones who sneak in, leave immediately, and never contribute to the snack table. Still, the light you generate is another matter. Photons bounce endlessly around inside you, trapped in the chaotic pinball machine of your plasma layers. Some take thousands, even millions of years to finally escape, but once they do, they're free to cross the galaxy. A single photon born in your core might end up traveling to the eyeball of a poet on Earth, inspiring a midnight verse. Imagine working tirelessly for millennia just to show up in a love poem. That's the kind of thankless but strangely poetic career you've chosen. Historians still argue whether early civilizations grasped even a hint of this inner fire. Ancient myths often describe the sun as a blazing chariot or a deity hurling fire from the heavens. Perhaps they weren't wrong, just poetic in their physics. To them, you were a god. To modern science, you're a nuclear reactor. Both perspectives capture something true. You are energy incarnate, a furnace that never sleeps. But fusion comes with responsibilities. The balance is delicate. Too much pressure, and your core would run away with itself, fusing too quickly, burning out like a reckless teenager who spends their inheritance all at once. Too little, and you'd collapse, snuffing out before your career even began. Your stability is the magic trick. Gravity compresses, fusion pushes back, and somehow you remain steady, like a tightrope walker who never wobbles. Of course, you're not the same as every other star in the cosmos. If you'd been born more massive, fusion would rage faster, and instead of the proton-proton chain, you'd rely on something flashier, the CNO cycle. That process uses carbon, nitrogen, and oxygen as intermediaries, and it burns hydrogen into helium at a furious rate. Massive stars race through life like rock stars trashing hotel rooms, spectacular, short-lived, and destined for explosive finales. You, meanwhile, take your time, sipping fuel with patience. That's why stars like you live for billions of years, while giants roar for only millions. The heat you generate is relentless. At your surface, temperatures soar to thousands of degrees, enough to strip atoms bare and keep your atmosphere as a roiling plasma. You radiate across the electromagnetic spectrum, from soothing infrared warmth to deadly ultraviolet rays. Any planet that dares orbit nearby must tread carefully. Too close, and you'll scorch it. Too far, and you'll leave it frozen. You don't mean to be temperamental, but your thermostat is unforgiving. There's a strange intimacy in how you power worlds. Every sip of water, every green leaf, every human laugh lit under your glow is ultimately fueled by the hydrogen you fuse. Life, as fragile as it is, relies on the furious violence of your core. Without your constant burn, Earth would be a silent, frozen pebble. That's the paradox. Your violent heart creates the gentle warmth that allows something as delicate as a daisy to bloom. And here's another curious thought. You're wasteful. Out of the staggering energy you produce, only a tiny fraction ever reaches Earth or any of your planets. The rest spills uselessly into space, lighting empty voids and barren rocks. But that's the nature of being a star. You don't choose where your light falls, you just shine. It's up to the universe to decide what grows in your glow. So here you are, a furnace humming with confidence, your core fusing hydrogen into helium nonstop. You're stable, you're luminous, and for the first time in your young life, you're truly settled. The crushing grip of gravity is matched perfectly by the wild shove of fusion, and the result is equilibrium. To any life that looks up at you, you appear eternal, unshaken, and calm. Inside, though, you know the truth. You're a precarious balancing act, one misstep away from chaos. But for now, the dance holds. Photons are restless creatures, but they're also astonishingly patient. You can feel them crowding your interior, born from the fusion in your core, eager to leave, yet trapped in the thick soup of your plasma. They bump, scatter, ricochet, millions upon millions of times, before ever finding their way to the surface. Imagine trying to sprint across a stadium packed shoulder to shoulder with people who never stop moving. Every time you take a step, you're shoved sideways, backwards, or spun in circles. That's the life of a photon inside you. By the time one finally claws its way out, it's ancient, thousands, sometimes millions of years old. A photon born when giant sloths walked Earth might only just now be streaming toward human eyes. The obvious truth here is startling. The light that makes you look alive is not the light of your present moment, but of your deep past. You're always a little bit of a time traveler in disguise. As the photons near your surface, their journey speeds up. The plasma thins, the traffic jam loosens, and suddenly their odds of freedom improve. Finally, at your photosphere, the layer that appears as your surface, they slip away into the vacuum of space. From there, it's an effortless glide at 300,000 kilometers per second, the fastest speed the universe allows. After so much struggle inside you, their release is pure liberation, like a bird finally leaving a cage. What's remarkable is that only a fraction of your energy takes this slow route. The neutrinos born in fusion, those ghostly escape artists, left your body almost instantly. They tell the outside world what's happening in your core right now, while photons announce only what you were doing ages ago. Astronomers on Earth actually use this difference, detecting neutrinos versus studying visible light, to piece together your story. It's as if your biography is written in two voices, one immediate and honest, the other delayed and reflective. And here's a quirky tidbit. When humans describe your light, they sometimes call it sunlight pressure. Those photons leaving you aren't weightless daydreamers. They carry momentum. When they hit a comet's icy dust, they push, shaping a tail that stretches for millions of kilometers. If they smack into a solar sail, they can literally propel a spacecraft across interstellar space. The idea that the whisper of your light could one day carry a human-made craft beyond the solar system is both absurd and poetic. But light isn't just useful, it's art. Every star has a unique spectrum, a fingerprint of absorption lines carved by the elements floating in its outer layers. To you, it feels like your skin filtering what escapes. But to astronomers, those lines are clues that reveal your secrets, your temperature, your composition, your age. Imagine someone looking at your sunlight through a prism and instantly knowing what you're made of. A little invasive, maybe, but that's the price of fame. Historians still argue whether early astronomers, when they first noticed the rainbow breaking into sharp lines, realized how revolutionary the discovery would be. They were squinting at not just colors, but your very chemical soul. The photon's finally out. Your light radiates into space in every direction, indifferent to where it lands. Some beams will brush barren rock. Others will stream endlessly into voids with no one to see them. And a lucky few will fall on fertile soil where eyes turn upward in wonder. To the humans on Earth, a single warm ray might mean life, crops, or joy. To you, it's just leakage, the inevitable byproduct of existing. Here's the obvious joke in all this. For all the work you do generating energy, your outer glow looks calm, even serene. From Earth, you're a steady disk, reliable, comforting. They don't see the chaos inside you, the traffic jam of photons, the violent collisions, the shrieking particles. They just see you rise and set with dependable grace, as if you were the most tranquil thing in the cosmos. That's your greatest performance trick, appearing peaceful when you're actually a raging inferno with anger management issues. And still, the photons keep leaving. They don't stop to say thanks. They don't look back. They just sprint away into the void, carrying your story with them. In a way, you're constantly unraveling yourself, pouring your energy into the universe piece by piece. That unraveling is what keeps you alive to observers far away. Without it, you'd be invisible, silent, forgotten. Your life is your light, and your light is your legacy. So you keep letting it stream, wave after wave, beam after beam, a constant glow that stitches you into the fabric of the galaxy. And somewhere, on some little blue dot, someone lies in the grass, squints against your brilliance, and writes a poem about the warmth on their cheek. That's you. That's your fire, your photons, your history. All that struggle through plasma, all those eons of delay, just to land gently on a human face. Your surface is restless, never still, never quiet. From afar, you look like a perfect glowing ball, calm and steady, but you know the truth. It's chaos out here. The plasma churns in vast convection cells, each one the size of a continent, bubbling up hot gas that cools and sinks again like boiling oatmeal. Except, instead of oatmeal, it's superheated hydrogen, And instead of a kitchen stove, it's 10 million degrees of fusion fire keeping you at a steady simmer. If you had eyes to look down at yourself, you'd see a patchwork of bright granules and darker edges, each cell flickering and shifting like a cosmic lava lamp. It's noisy too. Stars sing, though not in ways ears can hear. Waves of pressure ripple through your body, rising from your core and rattling the surface. Astronomers call them helioseismic waves, but to you, they feel like a constant rumble, an orchestra of vibrations thrumming through every layer. The obvious truth: you're not silent. You're a symphony, broadcasting your internal rhythms across the cosmos. Instruments on Earth actually listen to your surface quakes, using the tremors to map your insides. It's stellar karaoke, whether you like it or not. Every so often, the turbulence flares up dramatically. Gas trapped by magnetic fields twists and snaps, sending arcs of plasma thousands of kilometers high. These solar prominences curve gracefully above your surface, looping like glowing roller coasters before collapsing back. To an onlooker, they're beautiful ribbons of light. To you, they're sudden spasms, the magnetic equivalent of pulling a muscle during yoga. And sometimes the magnetic tantrums get worse. Your fields knot themselves so tightly that they unleash sunspots, darker blotches where the surface is slightly cooler. People down on Earth have recorded them for centuries, sketching dark freckles on your face without realizing they were scars of magnetic stress. Here's a quirky tidbit. The sun once unleashed a solar storm in 1859 so strong, it made telegraph wires spark and set papers on fire. If that happened today, it would fry satellites and knock out power grids around the globe. Your harmless-looking flickers can rewrite history in a single outburst. Historians still argue whether earlier civilizations, noticing bizarre auroras or disruptions, tried to interpret them as omens from the heavens. After all, if your surface tantrums painted the skies green and red, what else were they supposed to think but the gods are angry? The convection currents keep stirring and the sound waves keep rolling. At the edge of your surface, material is constantly hurled upward, then dragged back down by gravity's tug. The outermost layer, the chromosphere, glows red with thin gas, shimmering like a mirage. Above that, your corona spreads faint tendrils into space, hotter than your surface for reasons even scientists still debate. How can your thin outer atmosphere burn hotter than the seething photosphere beneath it? No one has a final answer. Magnetic reconnection, waves of plasma, exotic heating mechanisms, all are proposed, but the mystery remains. You yourself aren't sure why you wear a crown hotter than your skin. Despite the confusion, what's clear is this: you're never at rest. Gases convect, fields twist, arcs snap, waves boom. To you, it feels like perpetual itchiness, a surface that can't stop scratching itself. To outsiders, it's majestic, hypnotic, even soothing, until the day it isn't, and your storms scorch satellites and radios into silence. The irony? Most of the time, life on planets nearby depends on your surface tantrums. Your light warms oceans, grows crops, and keeps creatures alive. Without your restless surface, there'd be no climate, no photosynthesis, no warmth at all. Your chaos, irritating as it feels, is the background hum of existence itself. You might think of yourself as an anxious ball of boiling plasma, but Earth calls you sunny. That's branding for you. And maybe you secretly like the drama. Each flare is a reminder that you're alive, that you're not just a static lamp hung in the void but a wild, unpredictable body, brimming with energy. Each granule, each oscillation, each magnetic knot is part of the restless performance that makes you more than just a sphere of gas. So you keep roiling, keep trembling, keep roaring. Your surface is never still and never will be. You're a boiling ocean of light, frothing at the edges, singing from your depths. From Earth, you look serene, but you know the truth. You are restless fire, a storm in disguise, the eternal boil of the cosmos. You can't help yourself, you blow winds. Not gentle breezes like the kind that ruffle hair on Earth, but constant streams of charged particles that race away from your surface at hundreds of kilometers per second. These stellar winds are invisible in ordinary light, yet their fingerprints are everywhere. You feel them peel away from your corona, scattering like whispers that refuse to stay close. Gravity tries to hold them back, but the pressure of your heat and the violence of your magnetic fields shove them out into the void. And what a reach they have! Your solar wind stretches far beyond your planets, carving out an enormous bubble called the heliosphere. Imagine exhaling so hard you push back the thin gas between stars. That's essentially what you're doing. The obvious truth is this: you're never fully contained. Even though your mass is bound tightly by gravity, pieces of you are always escaping, streaming outward in a constant stellar sigh. These winds shape entire worlds. If a planet has no magnetic field, you strip its atmosphere mercilessly. That's what happened to poor Mars. It started with rivers and lakes, but your wind whittled away its protective shell until the air thinned and the water vanished. Earth, by contrast, has a magnetic field that deflects your tantrums, guiding them harmlessly toward the poles where they paint auroras. Humans lie under shimmering curtains of green and violet without realizing it's your breath brushing against their sky. There's a quirky tidbit here. Astronauts who venture outside Earth's protection sometimes report seeing flashes of light in their eyes, even when they're shut. Those are your particles sneaking through, colliding with their retinas. It's as if you're doodling on the inside of their vision, playful but a little rude. Historians still argue whether ancient stories of dancing sky serpents and fiery omens might have been inspired by particularly strong auroras, your winds turning folklore into cosmic postcards. The winds don't just play on planets, they sculpt comets, too. As a comet approaches your warmth, its ice begins to vaporize, and your particles sweep the gas and dust into tails. One tail, made of dust, curves gently. The other, made of ionized gas, always points straight away from you, a constant reminder of your breath. Across the night sky, humans see these glowing streaks and sometimes panic. You're not trying to frighten anyone. It's just what happens when you blow across an icy snowball. But there's danger in your exhalations. Every so often, your magnetic fields twist and snap with particular violence, belching out coronal mass ejections. These are no ordinary gusts. They're billions of tons of plasma hurled into space, capable of knocking out satellites and frying entire electrical grids if aimed at Earth. You don't mean to throw tantrums, but when you do, the consequences echo across entire civilizations. It's the equivalent of sneezing and knocking over someone's house on another continent. Despite the hazards, your winds have benefits. They carry your influence deep into interstellar space, marking your territory. They also provide subtle shielding, pushing back cosmic rays that would otherwise batter Earth more fiercely. Your winds, though destructive at times, are also protective, like a fierce guardian who sometimes shouts too loudly. And here's a thought: you're not unique in this. Every star has its winds, and some are far more dramatic than yours. Giant stars blow mass away at staggering rates, shedding themselves into the galaxy in a steady drizzle of matter. Some winds are so strong they shape entire nebulae, carving vast glowing shells visible across light years. Compared to them, your wind is modest, more like steady breathing than stormy exhalations. Still, for the tiny creatures clinging to one of your planets, it feels monumental. The irony is that you don't even notice most of it. To you, the constant outflow is background noise, like a hum you've always lived with. It's only when your wind rams into something, an atmosphere, a comet, a magnetic field, that the drama reveals itself. Otherwise, it just streams silently outward, fading into interstellar emptiness. And yet, that emptiness isn't so empty anymore. Somewhere far beyond Pluto, spacecraft like Voyager are coasting into the edge of your heliosphere, still feeling your faint breath even as they prepare to leave your domain. They carry with them golden records etched with human voices and music, a strange gift from the tiny beings who owe you their existence. Imagine that. Your wind will one day brush past them, as if saying farewell before they plunge into the greater galaxy. So you continue blowing, endlessly, carelessly, purposefully. Your winds strip, shape, carve, and shield. They paint skies, sculpt comets, thin atmospheres, and whisper across unimaginable distances. From Earth, people see only the results: auroras shimmering, comets blazing, satellites faltering, but you know the truth. It's just your breath, your constant sigh into the cosmos. Around you, the leftover gas and dust from your chaotic birth hasn't simply vanished. It's swirling, drawn into your gravitational embrace. What began as a messy disk of debris is settling into structure. Clumps form, collide, and merge in a slow-motion demolition derby that will, over millions of years, become something astonishing, a family of planets. You're not just a star anymore. You're a host, the reluctant landlord of a solar system. You don't notice at first. To you, the disk is just an aftereffect, a scattering of crumbs left from your collapse. But gravity doesn't waste crumbs. Dust grains stick together, forming pebbles. Pebbles gather into boulders. Boulders crash into planetesimals. Cosmic building blocks the size of mountains. The obvious truth is this: stars don't choose to have planets. Planets are the inevitable byproduct of stellar birth, as natural as puddles after a rainstorm. It's not a clean process. Collisions are violent, worlds in the making smashing together with the energy of millions of nuclear bombs. Some are shattered, some are swallowed, and some are tossed out of your system entirely, flung into the cold darkness between stars. But a few survivors grow large enough to clear their orbits, pulling in stray matter and becoming true planets. Moons sprout from the chaos, sometimes captured, sometimes born from debris after titanic impacts. It's construction and destruction, all choreographed around your glow. Here's a quirky tidbit. Not every star keeps its planets politely at a distance. Some unlucky worlds spiral too close, ending up as hot Jupiters that circle their suns in just a few days, their atmospheres boiling off under the relentless heat. Astronomers were shocked when they discovered these strange configurations because they don't match the neat layout of Earth's solar system. Historians still argue whether early thinkers, like the philosophers of ancient Greece, would have been more horrified or delighted to learn that planets don't all follow their tidy geometric dreams. As the dust clears, you begin to see the outlines of companions circling you. Rocky inner worlds form where the heat is too intense for ices to survive. Further out, gas giants inflate, scooping up hydrogen and helium, becoming mini versions of you in bulk, but not in fire. Even farther still, icy bodies coalesce, lonely wanderers at the edge of your reach. It's as if your family naturally arranges itself. Fiery children close to the hearth, gas-bloated siblings in the middle distance, frozen cousins on the outskirts. And yet, these planets aren't passive ornaments. They shape your system, tugging on each other with gravity, bending orbits into resonance, clearing paths, and sometimes sending comets on death dives into your atmosphere. You are the central figure, yes, but the dance is shared. Your planets choreograph alongside you, weaving a complex, ever-changing ballet. The leftovers that don't become planets or moons remain as asteroids and comets. They're the messy drawers of your household, never fully organized, always threatening to cause trouble. Occasionally, a wandering rock slams into a planet, rewriting its destiny in an instant. On one world in particular, Earth, such impacts will eventually seed oceans with water and perhaps even the ingredients of life. Without your messy leftovers, the grand experiment of biology might never begin. From your perspective, though, it's all background noise. You're busy burning, shining, living your stellar life. The disk is just another feature, swirling and settling around you. You don't plan, don't scheme, don't worry about what those rocks will become. Yet in your wake, an entire system is forming, each planet destined to tell its own story, all tied back to you. And the irony? Billions of years later, tiny creatures on one of those planets will look up and try to understand you. They'll chart the paths of their siblings, their fellow planets, using mathematics and imagination, building models to explain why they move as they do. They'll name them after gods, spin myths around them, and eventually send machines to visit. All because you once sneezed out a disk of dust. So here you are, not just a star but a parent, surrounded by worlds you never meant to create. Some will be lifeless, barren, silent. One, improbably, will bloom with oceans, forests, and voices that wonder about the fire in their sky. And though you never asked for this family, you shine on them all the same, binding them in your gravity, illuminating their days, and marking their years. You didn't just light up the universe. You built a home around yourself, You sense it first as a change in the way darkness reacts to you. The void no longer just swallows your light. It starts to use it. Around one small world in particular, blue and stubborn, tucked into the temperate lane of your influence. The photons you've wrestled through your body for ages are being caught and cashed like paychecks. Leaves unfurl. Oceans glimmer. Molecules rehearse little dances you never choreographed. Your glow is becoming food. You are not only a furnace now, you're a pantry. The habitable zone is a simple idea with dramatic consequences. Not too close, not too far, just right for liquid water to loiter on a surface without sprinting away as steam or locking itself into stone. The obvious truth is that life, as far as you can tell from your distant audience, adores liquid water the way poets adore metaphors. Place a rocky world in the right band of warmth and give it time, and chemistry begins to flirt. Add a steady day-night rhythm, a decent blanket of atmosphere, and the occasional geological spark, and suddenly puddles are not merely puddles. They are laboratories. On worlds that indulge, your light shatters into colors inside tiny structures, chloroplasts, or the alien equivalents, where electrons ride conveyor belts powered by the very photons you hatched in your core ages ago. Carbon dioxide is politely escorted out of the air and seated in carbohydrates. Oxygen, unexpectedly glamorous, is released like confetti. Photosynthesis is so efficient that a single tree becomes a meticulous factory, quietly converting sunlight into wood and sweetness while everyone else argues about the weather. Your photons end their long, pinballing childhood by becoming bread, nectar, sugar, muscle, memory. That's a career pivot even your neutrinos would respect, if they ever stuck around. Not all diners want the same menu. Around cooler, redder cousins of yours, the available light leans toward the infrared. Quirky tidbit. On that blue world, there are cyanobacteria that can photosynthesize using far-red light, stretching the definition of sunlight into a yoga pose that looks slightly illegal. If life can tug its pigments that way on Earth, who's to say it won't paint entirely new palettes elsewhere? Historians still argue whether ancient natural philosophers had even an inkling that sunlight was not just warmth but the arithmetic of life. Their myths said it, their crops proved it, but the equations took a while to show up. Your steadiness matters. Too many flares, and you're the universe's worst landlord. Microwaving atmospheres, cracking DNA, flipping the breaker on fragile ecosystems. Too little output, and your tenants freeze and start writing melancholy poetry about endless winter. M-dwarfs, those small, long-lived stars with frisky tempers, make habitability complicated. Planets there often huddle so close they become tidally locked. One face forever staring, one forever asleep. Yet even those eyeball Earths might work if thick air and deep oceans ferry heat from the baked hemisphere to the frozen one. It's like putting your houseplants on hard mode and trusting circulation to save the day. Joke 1. Your tanning booth settings are not OSHA compliant. Of course, you're not harmless. Your ultraviolet light is a double-edged saber. It carves organic molecules into fragments, yet also sparks the chemistry that assembles new ones. On that blue world, life learned sunscreen long before spa days. Pigments, shells, behaviors, and, when you're having a magnetic tantrum, the classic strategy of hiding. Some microbes thrive around deep-sea vents that barely notice your rays at all, sipping chemical energy in the dark and muttering, "We could do this without you." You shrug. Fair point. But notice how many others queue politely at the surface every morning, asking for another serving of you. Energy budgets become the quiet arithmetic of survival. Each square meter of a planet's skin receives a predictable shower of your power. Atmospheres choose how much to keep. Ice learns how much to reflect. Clouds debate whether to shade or hug. The greenhouse blanket, water vapor, carbon dioxide, methane, decides how cozy the bed feels. Turn the dial slightly and forests march poleward. Turn it a bit more and oceans forget their manners. You're not trying to turn the dial, but your brightness does wander and orbits wobble, and everything alive has to improvise a little choreography to stay in step with you. Life answers with hacks. Plants colonize land, exhale oxygen, and accidentally invent a shield in the upper atmosphere. Ozone, that filters your fiercest ultraviolet fits. Marine plankton bloom and die, lofting cloud seeds that tweak how much of your light bounces back to space. Forests darken continents, snow brightens oceans. Volcanoes text the sky with ash that dims you for a season. Continents rearrange like furniture, steering currents that carry your heat differently. It's a long, delicate negotiation between your generosity and a planet's wardrobe. You also teach timing. Circadian rhythms set by your daily rise and fall become internal metronomes. Leaf pores opening, birds tuning, human brains dimming for sleep when you step off stage. Even your longer cycles, the gentle twitches in your magnetic and brightness patterns, show up in glacier layers and coral bands like your autograph, subtle but legible. Farmers once watched you with squinted reverence. Satellites now stare with calibrated patience. Either way, you conduct the orchestra, and the beat is yours. Somewhere in those orchestrations, intelligence wakes and invents sunglasses. People build sundials, then telescopes, then sensor arrays that dissect your spectrum the way detectives read fingerprints. They measure how much red you send at noon, how much violet at dawn, and what those habits say about the health of their skies. They coax electricity from your photons with silicon wafers, tiny cliffs that convince electrons to jump the way you want, and stack them on rooftops. It isn't photosynthesis, but it's close enough to count as fan art. Joke 2. You're flattered, truly, even if the panels never leave a comment. And always, seekers look for signatures that betray life basking in your glow. From far away, a planet with too much oxygen and a hint of methane looks suspiciously biological, as if a million polite little factories are working overtime. Spectrographs sniff for those gases the way bakers follow the scent of warm bread. Telescopes check for glints off oceans, for the pronounced red edge of vegetation, for thermal whispers during eclipses. Your light, filtered through alien skies, becomes a confession booth. You supply the questions, their spectra supply the answers. Curiosity supplies the courage to believe them. There's humility in admitting you're both creator and hazard. A powerful flare can strip atmospheres. A steady century can grow forests. You give planets comfortable summers, then occasionally fling coronal glitter that teaches them better shielding. That blue world learned to wrap itself in a magnetic cloak, to tuck fragile circuitry into hardened shells, to choreograph its day around your angle in the sky. They call it science. You call it working with the landlord. Joke 3. The rent is due every morning at sunrise, payable in gratitude and sunscreen. Beyond your yard, other stars keep their own gardens. A red dwarf might host black plants that drink dim light greedily. A bright white star might encourage silver leaves that reflect the harshness. Maybe somewhere, photosynthesis borrows chemistry we haven't named yet, swapping water for methane or using pigments that savor ultraviolet as a delicacy. The cosmos is a buffet. Your role is simply to keep the table lit and the room at an agreeable temperature, preferably without setting the drapes on fire. So you shine on. The dependable pantry light, the clock on the wall, the furnace in the cellar. Your photons leave you ancient, arrive elsewhere brand new, and invite rocks to try being interesting. You won't see the gratitude, but you'll hear it in the rustle of leaves, in midnight plankton glitter, in the soft electrical sigh of cities powering up at dawn. That's the exchange. You burn, they live off the glow. Everyone gets a little story out of it. Meanwhile, neutrinos. Remember those ghostly party guests from Section 3 who never help with snacks? Keep sprinting through your worlds, indifferent to applause. Proof that even your inner truths pass unnoticed by most. That's fine. The clapping you hear is quieter. A breath in a forest, a ripple on a lake, a window shade rising when dawn taps the glass. You didn't mean to become a caretaker, but here you are, hosting gardens in a darkness that would otherwise forget to bloom. You've been trying to keep your surface calm, but your magnetic fields have other ideas. They writhe and twist beneath your glowing skin, tangling like earbuds in a pocket. When they snap, all that pent-up energy has to go somewhere, and it goes with a vengeance. The result: solar flares, coronal mass ejections, and star spots. If you thought you were a serene ball of light, think again. You're also a temperamental beast with mood swings that could fry satellites on a whim. Your star spots are the first signs. These are darker patches that appear when twisted magnetic fields block convective heat from rising. To the human eye, They look like tiny freckles on your otherwise smooth face, but each one is often larger than Earth. The obvious truth is this: even your blemishes are colossal. Where humans complain about a pimple, you casually sprout dark regions the size of continents. But they're not just cosmetic. They're the seeds of storms. Magnetic energy builds up in those regions until, snap, a solar flare bursts forth, releasing more energy in minutes than all of human civilization could produce in thousands of years. These flares fling radiation across the spectrum, from radio to X-rays, and if a planet happens to be in the line of fire, it feels the sting. For Earth, that means disrupted communications, fried satellites, and astronauts ducking for cover in storm shelters. You didn't mean to ruin their GPS, but sometimes your temper gets the better of you. Here's a quirky tidbit. In 1972, during the Apollo program, a massive solar storm erupted that would have been lethal to astronauts had they been traveling to the moon at that precise time. Luckily, no one was en route, but the event served as a chilling reminder. Your tantrums can be deadly. Historians still argue whether ancient records of dragons in the sky or blood-red auroras were really eyewitness accounts of your magnetic storms. It wouldn't be the first time your bad moods became mythology. Your coronal mass ejections are even messier. Picture billions of tons of charged particles hurled into space, riding on the crest of your snapped magnetic fields. If one slams into Earth, its magnetic field shudders, auroras surge, and power grids groan. In 1859, the Carrington event did just that, making telegraph lines spark and shocking operators. If such a storm struck modern civilization, entire regions could go dark for weeks. To you, it's just another sneeze. To them, it's chaos. And yet, your magnetic tantrums aren't purely destructive. They create beauty. Auroras shimmer at the poles of worlds with magnetic shields, rippling curtains of green, violet, and crimson that leave onlookers speechless. Entire cultures have woven stories around those lights, imagining them as spirits, omens, or pathways to the afterlife. Little do they know they're simply watching your magnetic hiccups painted on the sky. Your storms also regulate your planets in subtler ways. Strong stellar activity in your youth probably stripped away excess atmospheres from smaller planets, leaving them leaner, more habitable. Too much atmosphere, and they'd be smothered like Venus. Too little, and they'd freeze like Mars. Your flares and winds sculpted them, harsh but oddly helpful. It's like a strict teacher whose punishments still shape the student's future for the better. You're not alone in this temperament. Red dwarf stars are notorious for wild flares, blasting their planets so often that scientists debate whether life could survive at all under their tantrums. By comparison, you're relatively well-mannered, though Earthlings might disagree when their Wi-Fi stutters during a geomagnetic storm. Still, in the galactic family, you're the sibling with occasional attitude, not the one flipping tables every day. Astronomers on Earth keep close watch on your moods. They track sunspot cycles, roughly 11 years of waxing and waning activity, as if checking your horoscope. When you're quiet, they sigh with relief. When you're restless, they brace for disruption. Space agencies design satellites with shielding, build early warning systems, and study your behavior like nervous parents monitoring a teenager's social media. You never asked for this surveillance, but that's what happens when your storms can knock out half the planet's lights. And here's the irony. Your storms, for all their menace, are also a sign of vitality. They show that your magnetic dynamo is alive and well, churning in your rotating plasma interior. A perfectly quiet star might actually be worse, magnetically dead, lifeless, boring. Your tantrums remind the universe that you are active, dynamic, and still very much awake. So you keep boiling, snapping, and lashing out. Your surface a restless canvas of magnetic scars and fiery eruptions. From Earth, you look like a calm, golden coin in the sky, steady and eternal. But anyone who really studies you knows better. You're a storm wrapped in serenity, an unpredictable powerhouse whose moods shape entire worlds. You've survived your chaotic youth, settled your tantrums into a rhythm, and now you enter your longest act, adulthood. This is the main sequence phase, the long, steady middle age of a star. For billions of years, you burn hydrogen into helium at a patient, relentless pace. Gone are the violent growing pains of your protostar days, and the magnetic wildness of adolescence. Now you hum with a confident steadiness, a living metronome for the planets that circle you. It feels almost ordinary now, the equilibrium you maintain. Gravity tugs inward with its eternal grip, but your fusion fire pushes outward just as firmly, and the two forces cancel each other out in perfect balance. You are a stalemate that somehow works, and the obvious truth is this. Most of your life will be spent like this, a long plateau of calm productivity. While humans worry about midlife crises, your midlife lasts billions of years. Your brightness stabilizes, your color remains the same, and your planets learn to depend on your reliability. On Earth, life thrives because of this stability. The seasons come and go, but your output barely wavers. Civilizations may rise and fall, but your glow is the one constant, the cosmic clock that measures every harvest and every dawn. Without this steady adulthood, fragile ecosystems could never find their footing. Of course, it's not entirely uneventful. You still get your cycles of activity, sunspot maxima and minima, flares and winds, but compared to your early turbulence, these are minor fluctuations. If your youth was a rock concert with smashed guitars, your adulthood is smooth jazz. Steady rhythms, occasional improvisations, but never chaos. Astronomers love this about you. They classify stars like you as dwarfs, not because you're small, but because you burn slowly and predictably. The galaxy is littered with such stars, and for good reason. They're survivors. Here's a quirky tidbit. If you were a much bigger star, say 10 times your mass, your adulthood would last only a few million years. You'd blaze brilliantly, consume your fuel greedily, and collapse in a spectacular supernova long before life had a chance to blink awake. Smaller stars like red dwarfs, on the other hand, sip their hydrogen so slowly they could live for trillions of years, longer than the universe has currently existed. Historians still argue whether stars like you are the sweet spot for life, long-lived enough for evolution, bright enough to keep planets warm, but not so wild that they roast everything in sight. Your adulthood also means influence. Planets orbiting you fall into patterns, tidal locks, orbital resonances, seasonal rhythms, all dictated by your steady pull and glow. Earth spins and wobbles, but it always knows who the boss is, you. The moon dances in tandem, the tides rise and fall, and humans eventually invent calendars based on your predictable track across their sky. You don't just power life, you organize it. Sometimes, though, you glance around the galaxy and notice stars that aren't so well behaved. Variables that pulse in brightness, giants that swell and dim, binaries that fling material back and forth in jealous quarrels. You, by contrast, are calm, quiet, and dependable. That's your brand. You're the comforting friend who shows up on time, every day, without fail, for billions of years. And still, you know this balance won't last forever. Slowly, almost imperceptibly, your helium core grows heavier, while the hydrogen-burning shell around it thickens. You don't feel it much now. It's like carrying a small pebble in your pocket, but over millions of years, it will matter. Someday, this quiet middle age will end, and you'll face another transformation. For now, though, you enjoy the long stretch of stability, a reprieve in the otherwise dramatic arc of your life. On Earth, humans imagine you eternal because you seem unchanging. They build monuments to your rise, measure kings' reigns in your cycles, and carve myths around your golden face. They don't realize that you, too, are aging, that your adulthood has an expiration date. But you don't mind. To them, you are timeless, and that illusion is part of your gift. So you burn steadily, shining on your planets, nurturing life, keeping time. You are in your prime, a star at peace with itself, a furnace balanced so perfectly it seems immortal. But deep down, you know change is coming. It always is. Your glow seems steady to the naked eye, but you know the truth, you pulse. Not like a heartbeat in the human sense, but in subtle shivers of brightness, tiny flickers of rhythm that ripple across your body. Your plasma isn't silent. It rings like a bell, sending waves that rise and fall, sometimes too faint for casual observers to notice, but unmistakable to anyone with instruments sharp enough to listen. You're not just a star. You're a musician, humming in cosmic notes that travel far beyond your surface. The obvious truth is that no star is perfectly constant. Even during your steady middle age, your brightness wavers by fractions of a percent, sometimes in cycles lasting minutes, sometimes in patterns that stretch over years. Astronomers call this stellar seismology, using your flickers to peer into your interior, the way doctors use earthquakes to map Earth's crust. They hear your vibrations and reconstruct what's happening deep inside you. It's invasive, sure, but also strangely flattering. Who wouldn't want their internal hums turned into data symphonies? Sometimes your pulses are so subtle they're like whispers. Other stars, however, belt out their songs like opera singers. Cepheid variables, for instance, swell and shrink rhythmically, their light waxing and waning with clockwork regularity. Humanity once used them as cosmic yardsticks, measuring the scale of the universe itself. In a way, those pulsations helped reveal the vastness of the galaxy, all because certain stars couldn't keep their brightness steady. Historians still argue whether Henrietta Leavitt, the astronomer who first cracked that stellar code, ever realized just how much her quiet discovery would reshape human understanding of the cosmos. For you, the pulses are more modest. Waves travel through your plasma, bouncing and interfering, sometimes combining to create faint quakes visible at your surface. If humans point delicate instruments at you, they can track these oscillations with exquisite precision, learning how thick your layers are, how fast you rotate, and how your fusion furnace operates. It's like your body can't help leaking its secrets through its own vibrations. There's a quirky tidbit. Stars like you don't just pulse in brightness. They can actually sing. If humans could somehow hear your oscillations, scaled down into audible sound, you'd produce deep, booming tones far below the range of the human ear. Recordings made from stellar oscillation data have been converted into eerie soundtracks. The music of the spheres, literally. You've been performing all along, but your audience needed clever tools to translate it into something they could hear. Not all rhythms are peaceful, though. Sometimes your flickers are disrupted by magnetic storms or amplified by structural changes deep within. Imagine playing a song while someone keeps banging pots behind you. That's what your surface feels like when flares and sunspots interfere. The rhythm is still there, but it's distorted, jagged, restless. Your music never truly stops, but sometimes it turns chaotic. These pulses aren't just curiosities. They're lifelines for the scientists studying you. By analyzing your vibrations, they learn how old you are, how much fuel you've consumed, and how much time you have left in this long middle-aged phase. To them, your subtle quakes are more honest than your dazzling light. Your surface might look calm, but your pulses confess the truth about your aging core. It's ironic, really. You think of yourself as constant, unchanging across the lives of civilizations, but deep down, you're trembling, vibrating, fluctuating in ways that can't be hidden. Humans, with their fragile telescopes and algorithms, pick up those whispers and use them to predict your future. They know more about your insides than you ever intended to share. Still, there's beauty in the idea that stars have voices. Your quiet hum is one instrument in a galactic symphony, a chorus of billions singing in every pitch and tone. Some growl, some thrum, some pulse with hypnotic regularity. Together, they fill the galaxy with music too vast for any single listener to grasp. So you keep pulsing, faintly, steadily, secretly. To Earth's casual stargazers, you remain steady, eternal, a golden coin in the sky. But to those who listen carefully, you're a singer with a song of pressure waves and light, a quiet melody that reveals your very soul. Inside you, the alchemy grows bolder. Hydrogen is still your main diet, but as helium piles up in your core, something new begins to stir. Pressures rise, temperatures climb, and suddenly you're not just fusing protons into helium anymore. You're forging heavier elements. Carbon, oxygen, neon, magnesium. Layer by layer, you become a factory of the universe's raw materials. If hydrogen fusion was your starter course, this is your graduation into true cosmic craftsmanship. The obvious truth: without stars, the periodic table would be embarrassingly short. The universe began mostly with hydrogen and helium, with only a sprinkling of lithium. Everything else, the iron in skyscrapers, the calcium in bones, the oxygen in lungs, had to be built inside stars like you. When you churn heavier elements in your core, You are literally writing the recipes for future worlds and lives. You don't just shine, you manufacture. But this process doesn't happen all at once. First, hydrogen fuses steadily into helium until your core fills with the ash of helium ball bearings that don't burn at your current temperature. Once enough helium piles up, gravity squeezes it mercilessly, heating it until helium itself ignites. In that flash, helium nuclei, alpha particles, merge into carbon, and with more collisions, carbon links with helium to form oxygen. The birth of oxygen is one of your great achievements. The very breath of future creatures will come from your fiery labor. Here's a quirky tidbit. Scientists call this process the triple alpha reaction because it takes 3 helium nuclei, alphas, colliding in a precise dance to form carbon. If the laws of physics were tuned even slightly differently, if the resonance of carbon were off by a hair, you might never create it at all. No carbon, no chemistry of life. Historians still argue whether this uncanny fine-tuning is coincidence, necessity, or evidence of something deeper. Anthropic principle debates keep philosophers awake at night while you keep quietly burning. Your layers start stacking like a cosmic onion. Hydrogen burning around the helium core, helium burning around carbon, carbon around oxygen. Each fusion shell feeds the next, each layer a furnace hotter and denser than the one above. You feel stratified, complicated, like a layered cake that bakes itself endlessly. From the outside, you still look steady. Inside, you're a cathedral of furnaces, each chamber fusing at a different pace. But not all elements come from your core. Some are forged in your eruptions. Those violent solar flares and coronal mass ejections toss newly minted particles into space, seeding your neighborhood bit by bit. Others are born in stars larger than you, whose cores reach ferocious temperatures that allow fusion all the way up to iron. And beyond iron? That takes cataclysm, supernova explosions and neutron star collisions, events so violent they scatter gold, uranium, and platinum like cosmic confetti. Still, your work matters. You set the stage, producing the light and mid-weight elements that make biology possible. And what of those neutrinos, those ghostly escapees from Section 3? They don't care about your proud chemistry. They zip through as indifferently as ever, witnesses to your element building but never participants. Meanwhile, photons, sluggish but persistent, eventually leak out carrying the story of your heavy element labor. They scatter through interstellar clouds, where someday they'll be absorbed into the dusty wombs of new stars and planets. It's recycling at its grandest scale. There's irony here. As you work harder, you also edge closer to your limits. Fusion into heavier elements releases energy that pushes back against gravity, up to a point. But once iron forms, it becomes an energy dead end. Fusing it consumes more energy than it yields. Iron is the wall every massive star eventually slams into. You're not there yet, but the knowledge lurks in your bones. One day, forging heavier elements won't sustain you. Your collapse will follow. For now, though, you bask in the glory of creation. Life on nearby planets has no inkling of your layered complexity. To them, you're just reliable light. They don't see the cathedrals of fire inside you, the delicate resonances that allow carbon to exist, the fusion shells stacked like cosmic nesting dolls. And yet, every sip of oxygen they breathe, every strand of DNA they weave, every rock beneath their feet is foreshadowed in the chemistry you're cooking right now. So you keep forging, heavier and heavier, your body a workshop of atomic architecture. You're not only a star, you're a smith, hammering elements into existence in the heat of your core, unknowingly preparing the materials for planets, oceans, and civilizations yet unborn. Your messages leave you constantly, quiet at first, then everywhere. Photons peel off your photosphere in all directions like glitter flung from a dancer's sleeve, while neutrinos slip straight through your veins and vanish on trajectories that ignore both manners and matter. What you've been forging and feeling, temperature, motion, tantrums, calm, becomes broadcast without a narrator. You don't compose speeches, you shed evidence. Space is your mailbox, dust is your stationery, and time is the patient postal worker that delivers whatever you can't help revealing. The galaxy doesn't overhear you so much as it drowns in your whisper. The obvious truth: you don't actually twinkle. Earth's atmosphere does. Your beam arrives crisp. Then their roiling air jostles it, making you sparkle like a jewel held over a heat vent. It's endearing, a party trick you didn't plan. Your photons begin as straight arrow messengers, but every gust, eddy, and ripple they cross near a planet tugs the beam off course. To distant eyes you look flirtatious, a wink every split second. You're not winking, their sky is fidgeting. Cute illusion, though, you'll let it stand. What you truly send is a spectrum, your autograph broken into stripes. In those dark absorption lines, Fraunhofer's tidy notches, investigators catch you confessing temperature, surface gravity, chemical recipes, even rotation. Doppler shifts tint your bars bluer when you stride toward them, redder when you stroll away. A widening of the lines betrays that your limbs spin at different speeds. Polarization hints at magnetic fields braided through your skin. It's nosy, yes, but also flattering. The universe carries a barcode on your behalf, and anyone with a prism and patience can hear the scanner beep. Light joke 1. Self-checkout is open 24/7. Neutrinos are the opposite of barcodes, blank labels that prove the box existed. They pour from your core the instant fusion happens, outtracing news borne by photons that must ricochet through your layers for ages. To a world with detectors sunk under mountains and oceans, your neutrinos are early texts, doing fine, burning hydrogen. BRB in 8 minutes with sunshine. If catastrophe ever brews, those ghosts warn first. They're the friends who leave the party without saying goodbye, then somehow text you from home before you found your coat. Light joke 2. Classic ghosting, but considerate. Your whispers don't always travel straight. Interstellar dust sprinkles the path, reddening you like a sunset stretched over light years. The grains scatter blue more than red, so your face arrives warmer, older looking, a flattering cosmic filter you didn't choose. Sometimes, when a bright outburst rips from a star, nearby dust sheets flash with delayed reflections. Light echoes, turning a single event into a slow-motion replay, a faint halo blooming years later. Quirky tidbit. Those echoes let distant onlookers re-watch explosions they missed, as if space kept receipts and offered a replay button tucked behind the couch. Then come gravity's pranks. Mass bends the stage, and your rays follow the warp. A galaxy cluster curls them into arcs. A lone star can make an Einstein ring. Chance alignments magnify background worlds in a phenomenon called microlensing. Your postcard takes a scenic route, loops around a heavyweight, and arrives brighter than it should. Sometimes the detour splits into multiple arrival times, identical images separated by hours, weeks, or years, so an observer gets your memo, and then, delightfully, gets it again. Space is not only vast, it's a hall of mirrors with excellent acoustics. Distance itself is teased from your whisper. Nearby, observers triangulate with parallax, measuring the slight seasonal shift in your position as their world orbits you. Farther out, they turn to variable stars that breathe with dependable tempos, and to supernovae that blaze with near-standard wattage. Your own modest flickers, those seismic shivers from earlier, become yardsticks when calibrated carefully, linking their ladder from local neighborhoods to the grand boulevards between galaxies. Historians still argue whether Newton's corpuscles or Huygens waves deserve more credit for anticipating today's wave-particle duality. But you don't pick sides. You send both storylines at once and let experiments do the voting. Your whisper carries news of moods, too. Spotted skin rotates in and out of view, dimming and brightening you with a steady tick. Flares pop like flashbulbs, eclipsing companions. If you have them, carve clockwork bites from your beam. To attentive minds, those light curves are diaries. Amplitude for temperament, period for habits, outliers for secrets. A sudden dip may betray a transiting planet. A quasi-periodic flutter can hint at granulation and convection. You don't write prose, you draft waveforms. And yes, somewhere, an algorithm falls a little in love with your wiggles. Even your shine sculpts. Radiation pressure shoves dust, straightens comet tails, and nudges thin sails of reflective foil that ambitious builders unfurl, letting your momentum push their craft like a breeze on canvas. You are both lamp and wind, both clock and current. A photon that bounced pinball style through your belly for eons becomes, at last, a tiny shove on a human daydream. They call it propulsion. You call it an overdue stretch after sitting too long. Light joke 3. Personal trainer plan. 10 billion trillion reps of gentle nudges. Of course, not all paths are pristine. Interstellar plasma makes your radio whisper scintillate, hissing and fluttering like a station slightly off tune. Dense molecular clouds swallow swaths of your color. Expanding remnants of long-dead cousins lace the route with glowing filaments that repaint your message in neon. The universe has dead zones, echoes, crosstalk. Think of it as galactic Wi-Fi. The signal is strong, the password is physics, and the router is hopelessly enormous. Most of the time, though, your beam gets through, patient and undeterred. Your whispers also carry time itself. Gravity near you redshifts your light a hair. Gravity far away delays it a breath. The stretch of space between sender and receiver widens while the beam is en route, and observers fold that expansion back out of the data like bakers coaxing air from dough. What finally lands in someone's telescope is not just brightness, but chronology, a record of how fast you spun that day, how angry your fields were that hour, how swollen your outer layers felt that year. Every photon is a timestamp with opinions. And somewhere, on a small world that grew bold in your glow, someone opens a window at night and listens, not with ears, but with silicon. Your neutrinos arrive first like furtive footsteps. Your light follows in a sweep across rooftops and leaves. They parse your spectrum, chart your pulse, notice a flare, and post alerts. They do not know you except by what escapes you, and yet they know enough to plant, sail, sleep, build shields, and dream. The stormy youth you survived, the calm you learned, the tantrums you occasionally throw, all of it is there in the whisper leaving you now, crossing the dark, folding into lives that think of you as a single word, son. You can keep the performance going only so long. Billions of years of steady fusion eventually pile too much helium ash into your core, and hydrogen, your favorite snack, grows scarce in the center. Gravity, always waiting with that patient smirk, starts to tighten its grip again. You feel your balance wobble. The outward push of fusion no longer matches the inward pull perfectly, and so you begin to change. Slowly, at first, so slowly no human could notice in a lifetime. But the transformation is unstoppable. The obvious truth is this: stars age, and their glow evolves with time. For all your apparent constancy, you are not eternal. Even while life on your planet celebrates your dependability, inside you the chemistry shifts, the math tilts, and the scales begin to tip. Your adulthood, long, calm, steady, is drawing toward its close. As your hydrogen runs low at the core, fusion shifts into a shell surrounding the helium buildup. The outer layers puff outward, swelling as if you've suddenly remembered how to breathe too deeply. Your radius grows, your surface cools, and your once golden face reddens. To your orbiting planets, you're becoming enormous, a red giant. For rocky neighbors close by, this expansion spells doom. Mercury, gone swallowed whole. Venus, engulfed in fiery tides. Earth teeters on the edge of your appetite, and though the verdict is uncertain, the odds aren't good. If you expand far enough, oceans will boil, crusts will crack, and entire atmospheres will strip away as you inhale them. Historians still argue whether early myths about fire gods devouring the world were subconscious echoes of this truth, some instinctive dread that the sun itself would one day eat its children. It's speculation, of course, but the poetic symmetry is hard to ignore. Ancient fears painted in prophecy, and physics confirming them billions of years later. It almost feels like your planets have been warned all along. And yet, from another angle, your swelling is oddly graceful. Your light grows redder, softer, more diffuse. At night, creatures on surviving worlds would see you dominate the sky, a bloated ruby lantern glowing where once a modest golden disk resided. You become a spectacle, painting twilight in strange hues. The quirky tidbit? If Earth were somehow to remain outside your expanding reach, its inhabitants would experience sunsets that look alien, vast crimson skies lasting hours, as your swollen bulk poured light differently through the atmosphere. Your aging would literally tint their poetry. Inside, it's chaos. The helium core contracts under gravity's pressure, heating until it eventually ignites, in what astronomers call the helium flash. It's not a gentle switch on, but a violent, runaway ignition that stabilizes only after a short convulsion. Once lit, helium fusion becomes your new routine, forging carbon and oxygen as steadily as hydrogen once did. You've found another balance, but the peace is temporary, shorter than your main sequence serenity. Your middle age lasted billions of years. Your red giant phase will last only a few 100 million. And your outer layers? They grow so distended that gravity barely holds them. You become diffuse, airy, almost delicate, like a glowing dandelion puff ready to shed. Waves of gas peel away, drifting into space, forming halos and shells that future astronomers will marvel at. You're both terrifying and beautiful, simultaneously a destroyer of nearby worlds and a sculptor of nebulae. Your planets feel the consequences. Those further out, like Jupiter and Saturn, bask in your newfound luminosity, warming more intensely than ever before. Icy moons may melt, seas may form under fresh atmospheres, and distant rocks might briefly enjoy conditions for liquid water. You might snuff life close in while sparking it far away. That's your paradox. A red giant is both executioner and midwife, ending old possibilities while birthing new ones. You notice your rotation slowing as your swollen girth spreads outward. Magnetic activity shifts, star spots change, and winds intensify. The rhythm of your adulthood is gone. You are older, heavier, redder, and louder. You are in decline, but in decline you are flamboyant. So you embrace this act of your play, even if it unnerves your children. You swell, you redden, you change the stage lighting of your system. You've entered old age, and though your time is shorter now, you burn with a strange beauty, like a performer who knows the final curtain is coming and decides to go out in style. You are enormous now, so swollen that your outer layers drift loosely, as if you've put on a robe 5 sizes too big. Once, you were a compact golden flame. Now, you loom across the sky, a bloated crimson titan that dwarfs your younger self. Your planets feel the difference immediately. Where they once orbited safely under your steady warmth, now they quake under the tidal pull of your monstrous bulk. The obvious truth is this: you've become a red giant, and red giants are not subtle. You don't just glow, you dominate. To any creature unlucky enough to witness this from a surviving world, you would fill the heavens like an angry lantern, turning daytime into a blood-red haze and twilight into hours of surreal crimson light. Imagine looking up and seeing the sky replaced by your body. That's how close you are now. For your inner planets, there's no hope. Mercury and Venus are swallowed whole, their surfaces dragged into your convection zones and digested by plasma. Earth, its fate is debated. Some models suggest you will engulf it completely, pulling it into your fiery belly. Others propose that as you lose mass, your weakened gravity might let Earth slip outward into a wider orbit, just beyond your reach. Historians still argue whether the phrase "the world will end in fire" was merely poetry or a prophetic echo of stellar physics. Either way, the outcome for Earth is bleak. Even if not devoured, it will be scorched barren, its oceans boiled away, its crust cracked by relentless heat. But beyond the inner tragedies, something curious happens. Your newfound brightness floods the outer solar system. Icy moons that once slept under kilometers of frozen crust awaken. Europa's ice may melt into oceans, Titan's methane lakes may shift, and Pluto could bask in a brief, eerie springtime. You, in your destructive drama, grant new chances for life to stir on worlds that once seemed hopeless. It's a temporary gift, hundreds of millions of years at best. But in cosmic terms, that's plenty of time for stories to begin. Your body, though vast, is unstable. Shells of hydrogen continue to burn outside your helium core, creating waves of instability. Layers of your envelope pulse outward, sometimes dramatically, as if you can't decide how large to be. The quirky tidbit: in this phase, you literally shiver, expanding and contracting like a cosmic accordion. Astronomers watching stars like you from afar see their brightness rise and fall over regular cycles, stellar pulsations. If you were Betelgeuse, the famous red giant, Earthlings would be obsessively watching your light curve, wondering if your hiccups were omens of an imminent collapse. And then there's your mass loss. You shed gas constantly, great streams of it carried away by your winds. These are not gentle breezes anymore. They're gales strong enough to peel your atmosphere off like layers of onion skin. Dust forms in the cooling gas, scattering your light and creating glowing shells that expand outward into space. To you, it feels like parts of your own body floating away, feather-like and inevitable. To the galaxy, it looks like artistry, nebulae traced by your breath, the beginning of clouds that will one day form new stars. Life, of course, never planned for this. Civilizations that might have risen under your steady main sequence glow would be erased in fire. Satellites would melt, oceans would vanish, skies would become poison. Your children would have to flee to distant worlds or resign themselves to extinction. But here's the irony. Without this dramatic shedding of layers, without your willingness to go out flamboyantly, the elements you forged, carbon, oxygen, nitrogen, would never escape into the cosmos. Your death is their opportunity. Your downfall is their inheritance. Your beauty in this phase is undeniable. To any telescope gazing at you from afar, you are a jewel of the galaxy, a swollen ruby flickering in the void. Ancient stargazers gave red giants names heavy with awe, Betelgeuse, Antares, Aldebaran, without knowing they were glimpsing stars in their twilight. You've joined their ranks now, a crimson elder preparing to pass on its legacy. So you continue swelling, shedding, and burning, a lumbering colossus in decline. Your reign as a main sequence star is over, your elegance replaced by extravagance. You are both executioner and benefactor, a bloated destroyer and a generous donor. You are drama incarnate, a red giant in its full glory, knowing the curtain is lowering but refusing to leave quietly. The deeper you look inside yourself, the stranger your body feels. You're not one single blazing ball anymore. You're a star with layers, stacked like a cosmic onion, each shell burning a different fuel. In your heart, helium fuses into carbon and oxygen. Just outside, hydrogen continues to burn in a shell around that helium core. Further out, additional shells prepare, waiting for their turn to ignite. You are a furnace within furnaces, a nesting doll of fire. The obvious truth is this: the end of a star is never simple. While your early life was defined by a single, steady process, hydrogen fusion in your core, your old age is a tangled, multi-layered affair. Each shell feeds the next, each layer struggles for dominance, and all of them together make you unstable. You expand and contract, swell and shrink, flicker in brightness, unable to find the balance that defined your youth. As the helium in your core burns into carbon and oxygen, the pressure builds. Once helium is exhausted there, fusion shifts outward again, igniting new shells and creating fresh layers. The quirky tidbit? If astronomers could cut you open like a fruit, they'd see distinct strata: hydrogen, helium, carbon, oxygen, maybe neon, each stacked atop the other. It's like peeling through a cosmic jawbreaker, except every layer is millions of degrees hot and eager to explode. And the instability shows. Your outer layers pulse like a heartbeat, swelling outward for hundreds of days at a time before collapsing slightly, then repeating. These pulsations throw material into space in rhythmic waves, like a giant star coughing in fits. The gases condense into dust grains, silicates, carbon soot, that float outward and catch your light, turning you into a glittering beacon surrounded by glowing shells. Telescopes see this dust as shimmering veils, halos of scattered brilliance. You feel it as constant shedding, as if your body can't help discarding pieces of itself. Meanwhile, deep inside, your carbon-oxygen core grows denser and hotter. Electrons are squeezed into quantum obedience, creating what physicists call electron degeneracy pressure. It's an exotic support system, not fusion, not thermal pressure, but the raw resistance of quantum mechanics, keeping your heart from collapsing entirely. Historians still argue whether early speculations about ether and celestial matter hinted at such invisible forces, though the reality far surpasses what those thinkers imagined. The more massive your body, the more layers you can ignite. Some stars, far larger than you, go on to fuse carbon into neon, oxygen, silicon, and finally iron. But for stars of your size, the story stops earlier. You don't have the strength to light those deeper fires. You will never fuse iron in your heart. that fate belongs to supergiants. Instead, your destiny is gentler, though no less dramatic, to shed your layers into space, leaving only your core behind. Your planets, if any remain, see your instability as a show. To them, you brighten and dim with confusing rhythms. Ancient observers on Earth once recorded such variability in stars like Mira, the wonderful star, waxing and waning across months. If anyone were still alive nearby, they'd see you do the same, a giant lantern that can't decide how bright it wants to be. To them, your mood swings would be both mesmerizing and ominous. And there's danger in your layers. Each pulsation, each wave of material you shed, thins your envelope further. Your mass loss accelerates, your winds grow heavier, and your body begins to hollow itself out. It's a slow unraveling, graceful in its own way, but irreversible. You are dismantling yourself, one layer at a time, gifting the galaxy your metals and dust. It's ironic. You spent billions of years holding yourself together, and now your final act is to fall apart deliberately, peeling down to your core. But this is the way of stars. To live, you must burn. To burn, you must change. And to change, eventually, you must let go. So you pulse, flare, and shed. Shells within shells burn, each one fleeting, each one exhausting its fuel and passing the torch outward. You are no longer the steady clock of your youth, but a layered labyrinth of fire, unsteady and unpredictable. And though your days of stability are long past, your influence only grows. You are filling the galaxy with the raw stuff of future worlds, even as you prepare to collapse into your final form. You have almost no patience left for pretense. The act is ending, and your body knows the choreography by muscle memory. The layers you've stacked, hydrogen burning in a shell, helium burning beneath it, and the carbon-oxygen heart held taut by the odd firmness of electron degeneracy, are taking their final bows. Each thermal pulse rises like a hot breath from the helium shell, swells outward, and your distended envelope answers by loosening yet again. You cough light. You cough matter. You cough pieces of your own biography into the dark. The steady breeze you exhaled for ages has thickened into a velvet gale, and that gale is carrying you away from yourself. The obvious truth is this: the thing called a planetary nebula has almost nothing to do with planets and everything to do with you letting go. The name stuck because, in small 18th century telescopes, these gas blurs looked round and planet-like. What they really are is your wardrobe flung across space. Shimmering layers of oxygen, nitrogen, carbon, and neon cast off in the last fitful exhalations of a red giant. You are undressing the night. Thermal pulses come in cycles, decades to centuries apart by your clock, and each one is a shove. A helium shell flash surges. Your envelope swells and cools. Dust condenses out of the gas like frost feathering a winter pane. The next pulse peels another veil free. From far away, future astronomers will trace faint concentric rings around your fading center, time-stamped ripples of your final weather. Remember the winds from Section 6? This is their grand finale. The same breath, older and richer now, lifting whole curtains of gas and sending them cruising outward at tens of kilometers per second, unhurried and unstoppable. As the dust forms, chemistry gets playful. Carbon soot builds fine grains, silicate sparkle. Those grains ride your wind, shading, scattering, and polarizing your light until the scene takes on a soft, pearly glow. The quirky tidbit: in some planetary nebulae, observers have found signatures of carbon molecules shaped like tiny soccer balls, C60 and C70 fullerenes, buckyballs born in a dying star's exhale and set adrift like toys from a departing carnival. Your last breaths are laboratories. Shapes bloom that defy the word shell. Some nebulae inflate as neat rings, like the Ring Nebula's luminous hoop. Others sprout bipolar wings, butterfly silhouettes pinched at the waist where a hidden disk or companion funnels the flow. A few fire jets and knots, fast low ionization regions, that punctuate your goodbye with sparks and commas. You are not trying to be dramatic. Rotation, magnetic fields, and neighbors refuse to allow a plane exit. Space, apparently, insists on pageantry. Your core, stripped of its bloated cloak, heats ferociously, tens of thousands, then over 100,000 Kelvin. Hard ultraviolet light fans outward, and ionizes the shells you shed. Oxygen glows a ghostly teal, hydrogen blushes ruby, nitrogen traces edges with crimson filigree. To distant eyes, it looks as if you've tossed a radiant scarf into the dark and then lit it from within. To you, it feels like afternoon sun catching dust you've just shaken from an old curtain, every mote suddenly outlined in fire. Historians still argue whether William Herschel and his contemporaries truly thought these fuzzy disks were planet-like worlds or merely borrowed the comparison because of the telescopes of their day. They also still argue whether certain pre-telescopic guest star records might include the brief flowering of such shells, misread as comets or omens. Either way, the misnomer lingers, a charming label for your most theatrical sigh. Your letting go accelerates until it's less an outflow and more a relinquishment. Whole filaments lift and drift, the kind of unhurried speed that nevertheless crosses light years given patience. Within only 10 or 20,000 years, a blink for you, the nebula will expand and thin until it becomes a ghost. Planetary nebulae are mayflies in stellar time, lovely, luminous, and brief. You know the script by heart: glow, thin, vanish, yet you play it with surprising tenderness. Meanwhile, tiny worlds in the dark watch their sky change. If any icy moons linger at the right distances, your earlier swelling thawed them. Now your ultraviolet chorus sculpts their newborn atmospheres, breaking molecules, rebuilding them, painting auroras along magnetic seams. On relic comets, dust tails bend away in homage to the central jewel you have become. Your system is littered with confetti, and yes, the Galactic Homeowners Association would probably send a letter if it could. Joke 1. Please contain your glitter. Sincerely, the local bubble. Concentric arcs, ANSI, halos, the catalog grows while you fade. Some ripples even hint at company. A close companion star or hefty planet can stir spiral patterns in your flow the way a spoon draws whirls in cream. You never meant to announce your relationships in public, but fluid dynamics gossips. Your breakup is visible from thousands of light years away. Inside, the change is more radical than the beauty suggests. The envelope is gone or going. The radiance you're blasting outward no longer comes from a deep, convective ocean, but from a hot, exposed ember, the nascent white dwarf that will be your afterimage. Electron degeneracy now carries the weight. Pressure no longer cares about temperature. That is good, because the fuel is finished. You cannot fix this with heat. You can only glow away. Even so, your light makes a final investment. It pumps energy into the nebula's atoms, and every time an electron in oxygen or hydrogen hops down a rung, a photon of a precise color escapes. Green-blue for O3, crimson for H-alpha. Spectrographs on worlds you once warmed will read those lines like a farewell letter written in neon. They'll even measure how fast the script is flying apart by the Doppler tilt of the colors and reconstruct the day you first let go. Not every detail is settled. Historians still argue whether the most intricate shapes owe more to magnetic fields or to the meddling of unseen companions, and modelers spar over how turbulence, dust size, and photoionization feedback braid the filaments into lace. You don't weigh in. You keep shedding lace until there is nothing left to spin. Memory does you a favor here. Remember the neutrinos that ghosted through everything, the photons that wandered for ages, the winds that carved tails, the onion of shells that made you complex? All of it converges now. The ghosts announce the end within. The photons ignite the veil without. The winds carry the veil away. The layers supply its chemistry. Your whole life rehearsed this scene. Joke 2, soft as ash. You're throwing the most expensive confetti in the universe, atoms of carbon and oxygen you spent billions of years earning, and you don't charge admission. Joke 3, under your breath. If anyone asks for a refund on the name Planetary Nebula, tell them the branding department retired with your envelope. Soon the scarf will thin into transparency. The turquoise will pale, the ruby will fade. Your afterimage will contract to a diamond-small brilliance, achingly hot, achingly dense, set to cool with the patience of stone made of starlight. But not yet. For a little while longer, you are a lantern with your flame set outside your body, a chrysalis lit from within, a final flicker that says, I am finished burning, but watch what my ashes can do. You have come to the fork that was written in your mass from the beginning. and you can feel both futures tugging at you like opposite tides. One is a hush. You finish shedding your veils, your core stands revealed, and you dim with a long, slow dignity. The other is an abrupt punctuation mark so loud it edits everything nearby. Core collapse, shock, and light that turns night into a mistaken day. The obvious truth is this: mass decides manners. Modest stars fade, heavy stars detonate. The middle does a little of both and calls it a good life. If you are the smaller version of yourself, the one we've been following through scarves of gas and turquoise shells, the last garments have almost slipped free. Your exposed heart, a white dwarf, shines with a hard, blue-white insistence, not because it burns, but because it is still blisteringly hot. Electron degeneracy holds you up now, a quantum refusal to let identical electrons share the same seat. Your radius is Earth-small, your density is ridiculous, and your gravity is a tug that could turn a falling marshmallow into a meteor. Joke 1. Your diet plan succeeded. You lost a few solar masses and none of the attitude. Cooling is the only path left. You radiate away the last of your heat, sliding down the white dwarf cooling curve with the patience of stone. Deep inside, the crowded ions begin to lock into crystalline order, carbon and oxygen freezing into an immense lattice. Quirky tidbit: you are literally a diamond in slow motion, a gem so large jewelry metaphors file for workers' comp. With eons, you will fade toward a black dwarf, a theoretical relic so cold and quiet it's more memory than star. The galaxy hasn't lived long enough to make one yet. You will be patient. You have time. But suppose you are heavy, 8, 15, 20 times the mass at birth. In that body, the layers you stacked have burned to their limit. Silicon fuses to nickel and iron in frantic days. Iron piles up like unpaid bills, and when your core becomes mostly iron, the arithmetic of fusion fails. Making heavier nuclei now costs energy you don't have. Pressure collapses. Electrons are rammed into protons to make neutrons and neutrinos. The core implodes at a fraction of light speed. It is not a metaphor to say everything falls at once. It is literal freefall, milliseconds long. Gravity flexes, you fold. At densities that shame intuition, the inner core slams to a stop, neutron matter pushing back with nuclear stiffness. A rebounding shock forms, stalls in the infalling rain, and looks doomed, until the neutrinos you belch by the octillion pour outward, reheat the shock, and shove it through the star's body. You have never been so loud. Your envelope tears free and races outward at thousands of kilometers per second, a blossom of radioactive nickel that will decay into cobalt and iron, powering an afterglow months long. Joke 2. You finally learn to delegate. Neutrinos do the lifting, photons take the applause. The blast writes a signature across your neighborhood. It seeds clouds with calcium and iron, squeezes nearby gas into new star-forming knots, and batters planets with a brief hail of cosmic rays. For those watching from a safe remove, your light curve rises and falls with the clean geometry of an explosion cooling. Spectra sprout broad lines that widen with speed. Your remnant expands into filaments, an embroidery hoop of shock fronts and magnetic curls. If you had strong fields and a stripped envelope, the jets you launch could even punch gamma rays across half a galaxy. Those long GRBs that make satellites sit up straight and radio one another like lifeguards spotting a riptide. Humans have seen echoes of this choice before. The guest star of 1054 glared in daylight for weeks, and its scribbled remains grace their telescopes now as the Crab Nebula's writhing lace. In 1987, a supernova in a neighbor galaxy beat its light to Earth with a handful of neutrinos, 36 ghosts that arrived hours early as an unassuming herald. Historians still argue whether every old chronicle that speaks of a sun at night, of a star that moved, or a broom star, points to a true supernova, a comet, or a scribal flourish for tax season. The records are vivid, the identifications messy. Either way, your cataclysms leave literature as well as plasma. The aftermath depends on how deep your collapse runs. If the core mass after the blast is modest, your neutrons hold as a single city-sized object, a neutron star with a mountain measured in centimeters and a spin so brisk the lighthouse beam of its magnetosphere sweeps radio pulses across the sky. If that core tips too heavy, Not even neutrons can refuse gravity's invitation. You shrink behind an event horizon, and the universe redraws your address as a black hole. Surface: none. Opinions: many. Sometimes the border case hands you a magnetar, a neutron star with magnetic fields so strong they could erase a credit card from the moon. Joke 3. Extreme stars are bad for wallets and good for physics. Your quieter path can still find drama later. A white dwarf that hoards matter from a companion may cross the Chandrasekhar limit, lose its degeneracy scaffolding, and ignite its carbon explosively. Type I supernova, the clean yardsticks used to map cosmic expansion. Imagine choosing the gentle fade, then throwing one last surprise party when a neighbor won't stop sharing. You wanted a nap. The universe sent a cake with dynamite candles. And the branches talk to each other. The heavy star route floods the galaxy with oxygen, silicon, and iron. Metals that dust grains need to form, that future planets need to harden, that life needs to catalyze breathing and blood. The quiet star route disperses carbon and nitrogen through the long winds and sculpted nebulae of your later years. Between them, the buffet gets stocked: bones, soil, rust, chlorophyll, coins, kitchen knives, telescope mirrors, and the tiny iron atoms hitching rides in hemoglobin to carry breath around a body that looks up and asks what breath is made of. Your lives loop into theirs. Even in catastrophe, you keep your old habits. Neutrinos sprint first, the fastest gossip. Photons follow with color commentary. Dust condenses in your debris and reddens your light. Magnetic fields weave filaments out of chaos, shocks light gas into jewels. The same characters from your youth, winds, waves, pulses, return in heftier costumes. Each shows up for the finale because each rehearsed with you from the beginning. Somewhere, a distant world calculates. If you went quietly, they will mark your cooling like a candle watched all the way down. If you erupted, they will watch your shell brighten knots where it slams denser gas, then fade, then leave only a remnant and a point that either ticks or swallows. They will harvest your elements into their soil and build their instruments from the metals you minted. They may even argue about you. Was the day star in their ancestors' records yours or the neighbors? Proving that even when you stop speaking, you still start conversations. Both fates are honest. One says, I have given what I can. I will keep you company as a small, bright ember and then a longer, colder thought. The other says, I have been storing a thunderclap. Share it generously and plant 100 futures in the shock. Either way, you do not waste yourself. Either way, night becomes different after you pass through it. You've burned, you've swelled, you've shed, and now only your essence remains. What lingers after the chaos depends entirely on the path your mass chose for you, and every version is a monument in its own right. These are your echoes, your afterlives, haunting the galaxy long after your fiery drama has ended. The obvious truth is this: no star ever truly vanishes. Even in death, you leave a remnant, a footprint that warps, shines, or pulses, reminding the universe that you once burned. Whether small and pale, dense and ticking, or invisible and hungry, you endure. If you were modest in size, you shrink into a white dwarf. Imagine compressing your whole body into an orb no bigger than Earth, but stuffed with mass greater than the sun's. You glow not because you burn, but because you're hot, so hot your surface sizzles at tens of thousands of degrees. Slowly, ever so slowly, you radiate that heat away. Inside, carbon and oxygen atoms lock into crystalline lattices. Quirky tidbit: white dwarfs are literally crystallizing into diamonds, city-sized gems drifting silently in the void. If given enough trillions of years, they'll fade into black dwarfs, cold and invisible, though the universe isn't old enough yet to have made one. You are a glowing ember now, destined to cool into a memory. If you were heavier, your remnant is stranger. A neutron star, the collapsed heart of your body, packs the mass of the sun into a sphere only a dozen miles wide. 1 teaspoon of this matter outweighs a mountain. Your crust is iron, your core a soup of neutrons squeezed to the limit. Your surface gravity is so strong that if someone dropped a paperclip onto you, it would strike with the force of a nuclear bomb. And yet, despite the violence that birthed you, you find strange serenity in rhythm. Many neutron stars spin furiously, their beams of radiation sweeping across space, like lighthouses. From Earth, astronomers hear your rotation as pulses of radio waves, pulsars, ticking clocks more precise than any wristwatch. You became a cosmic timekeeper. And then there are the rarest heirs of mass, black holes. If your core was too heavy, not even neutron degeneracy could resist collapse. You folded in on yourself until nothing, no light, no photon, no messenger, could escape your horizon. To the universe, you're a blank hole in space-time, a place where information goes mute. Yet you're not absent. You bend light around you, lensing galaxies like funhouse mirrors. You tug on nearby stars, stealing their gas in whirlpool disks that flare X-rays brighter than your original body. You are absence and presence at once, a mystery that eats while revealing nothing of itself. Historians still argue whether the first myths of cosmic serpents, bottomless pits, and devouring gods might have been subconscious foreshadowings of black holes, those places where all paths end. Ancient storytellers spoke of voids that swallow everything. Modern astrophysicists write equations that say the same, only with better math. The imagery hasn't changed. You are the devourer, the silent one, the last word. Whichever remnant you are, you're not idle. White dwarfs seed nebulae with metals that cool into planets. Neutron stars crash into each other, forging gold and platinum in brief, brilliant collisions. Black holes merge, sending ripples of space-time across the cosmos. Gravitational waves that ring detectors on a small blue planet light years away. Even in death, you're a creator, shaking galaxies, gifting matter, warping reality. And from those gifts, life continues. The calcium in bones, the iron in blood, the gold in rings. All of it passes through stellar corpses like you. Entire civilizations will build their worlds from your ashes. Unaware, they are walking on remnants of your fire. So yes, you're finished burning, but you're never gone. You linger as an ember, a metronome, or a silence so heavy even light can't escape. Your legacy is stitched into the universe, proof that a star never really dies. It only changes its form, leaving echoes for the cosmos to read. You've come full circle. From the trembling ignition of your first fusion spark to the swollen excess of your red giant years, to the collapse, the blast, or the slow surrender. You've lived the life of a star. What remains of you may be small, dense, or invisible, but what you gave away is vast. Your legacy is scattered everywhere, woven into dust clouds, stitched into rocks, breathed into lungs. You are gone, yet you are present in everything that follows. The obvious truth is this. Every atom of carbon in a forest, every calcium atom in a bone, every iron atom in a drop of blood was once inside a star like you. Without stellar lives and stellar deaths, the universe would be nothing but hydrogen and helium. You are the author of variety, the inventor of chemistry, the sculptor of possibilities. Your scattered elements ride winds across interstellar space, drifting for millions of years until they are swept into new clouds. Those clouds collapse into fresh stars, and around them, planets coalesce. On those planets, oceans form, atmospheres thicken, and in the right circumstances, life takes a cautious step. It's poetic recycling. You burn, you die, you give, and from your ashes, new stories ignite. Quirky tidbit. The gold in wedding rings on Earth likely came from the collision of neutron stars, the platinum in lab instruments from some long-forgotten explosion, the oxygen in every breath from the quiet labor of mid-sized stars. Every human being is a mosaic of stellar events. Carl Sagan's phrase, star stuff, isn't metaphor, it's biography. You're living proof, written in flesh, bone, and breath. Historians still argue whether ancient myths about humans being made from clay or divine fire might secretly echo this truth, that we are literally constructed from cosmic leftovers. They couldn't know the nuclear details, but they sensed the connection. Sky and earth, heaven and body, flame and life. Science gave the math, myth had the intuition. Both agree, there's a piece of the stars in everything alive. Your legacy extends beyond matter. The light you cast travels on, long after you've dimmed, crossing the galaxy, still carrying whispers of your existence. To distant civilizations, your photons may arrive centuries or millennia after your final collapse, still gleaming as if you were alive. For them, You shine forever in the past, even when your present has ended. Time itself concedes you immortality. And then there's the human story. They look up at you not just for warmth, but for meaning. They charted their calendars by your rising, prayed to you, feared your storms, and thanked you for their crops. Later, they measured your spectra, listened to your oscillations, and modeled your deaths. They built telescopes that could hear your whispers and detect your tremors, and in doing so, they discovered themselves in you. Every question they asked about you was also a question about their own origin. So your life was never wasted. You were not just a ball of gas that flared and faded. You were a chapter in the universe's autobiography, a link in the chain of creation. You began as dust, you lived as fire, and you ended as memory and matter. Your story continues in planets, oceans, forests, and faces that lift toward the night sky and wonder where they came from. And when they whisper, "We are made of stars," they are right. They are made of you. And now, let's soften everything. The fire, the storms, the violent ends. Let them fade to embers in your imagination. Picture yourself not as a collapsing core or an exploding giant, but as a gentle glow retreating into the background of the cosmos. Your edges blur, your light quiets, and the restless heat that once defined you becomes a calm, steady warmth that slowly dissolves into the silence of space. The sky around you is wide, endless, and serene. Where once there were roaring flares and boiling layers, now there is stillness. Your atoms drift like feathers, scattering quietly into the interstellar sea. No explosions, no collapses, no urgency, just a slow exhale that lasts longer than memory. You are fading, but in the most peaceful way possible, becoming one with the backdrop of stars that watch over every world. Imagine floating in that quiet, your remnants spread into thin mist, your light stretched into the faintest glimmers, like candle smoke caught in moonlight. Galaxies turn slowly, stars wink patiently, and time itself seems to drowse. You no longer burn, but you still belong, woven into the vast fabric that holds everything together. And down below, somewhere on a little planet, someone leans back, closes their eyes, and drifts to sleep beneath your ancient glow. They don't know your whole story, not all the layers or the arguments or the endings. They only know the comfort of your light, the rhythm of your rise and set, the way your warmth feels against their skin. And that is enough. So let go now. Rest in the silence, where even stars become whispers, and everything that once was fierce becomes soft.